Hello dear students, welcome to chemistry class, and in this class we are starting one of the new chapter from your syllabus, that is unit 2, chemical bonding and molecular structure. Chemical bonding and molecular structure, and under this unit we are going to discuss about the ionic bonding and covalent bonding, and the syllabus includes the definition and example and the factors which are affecting the ionic bonding, lattice energy, statement of Born-Lande equation for calculation of lattice energy, Born-Haber cycle and its applications, polarizing power and polarizability, and Fuson's rule, ionic character in covalent compounds, and bond moment, dipole moment, and percentage of ionic character. And in covalent bonding, we are discussing about valence bond approach and molecular orbital approach. And in valence bond approach, shapes of some inorganic molecules and ions on the basis of VSEPR, that is valence electron pair repulsion and hybridization, with suitable examples of linear, trigonal planar, square planar, tetrahedral, trigonal bipyramidal, and octahedral arrangements. And in molecular orbital approach, rules for the LCAO, that is a linear combination of atomic orbitals method, bonding and antibonding molecular orbitals and their characteristics for SS, SP and PP combinations of atomic orbitals, and a non-bonding combination of orbitals, molecular orbital treatment of homonuclear diatomic molecules of first and second period, that too including idea of sp mixing, and heteronuclear diatomic molecules such as CO, carbon monoxide, NO, nitric oxide, and NO plus, that is nitrosonium ion. Then the last concept is comparison of this VB approach with MO approach. Okay, this is all the syllabus what we are going to discuss under this heading, chemical bonding and molecular structure. Okay. Then let me start the syllabus. And here all we know that the periodic table is containing 118 elements, and out of these 118 elements, except noble gas, atoms of all other elements have no free existence. Except the atoms of noble gases, the atoms of all other elements have no free existence. Free existence means they are not available in their actual form, and they are available to us in their compound or molecular form. They are available to us in their compound or molecular form. Take for example hydrogen. It is not available to us in H form. It is available to us in H2, HCl, H2SO4, H2O, etc. And these are all called molecules or compounds of the hydrogen. Okay. Then while forming the compound or molecule, these atoms are held together with a special type of force, and this force itself is called a chemical bond. In forming the compounds or molecules, the atoms are held together with a special type of a force, and that force is nothing but a chemical bond. Then coming to the particular definition of chemical bond, here I am writing the definition for chemical bond. This chemical bond can be defined as an attractive force which holds two or more atoms or ions together to form a compound or molecule. This is the definition for chemical bond. Chemical bond can be defined as an attractive force which holds two or more atoms or ions together to form a compound or a molecule. Okay, this is all about what a chemical bond. Then now you may ask one question, sir, why the atoms are combining? Why not the atoms of noble gases are combining to form the compounds or molecules, but the atoms of all other elements excepting the atoms of noble gases are combining to form the molecular compound? The first question is why the atoms of different elements are combining. Then the next question, if they are combining, how they are combining? These two questions are arising in your mind. Okay, I will clear these two questions. See here, why the atoms are combining? We all know that in this universe each and every system is working only to get stability. Each and every system is working only to get stability. Like that, the atoms are also combining here only to get stability. Only to get stability. Then now you can ask, how can you say, sir, whether this atom is stable or not? And here we know that an atom, say X, an atom X is said to be stable only when it is having 8 electrons in its valence cell. 8 electrons in its valence cell or 8 electrons in its outermost orbit. Then only we can say that this atom X is stable. This rule is called what? Octet rule. Octet rule. According to this rule, an atom is said to be stable only when it has 8 number of electrons or octet number of electrons in its valence cell or outermost orbit. Okay. Take for example about the noble gases. Here I will write the noble gas: helium, neon, argon, krypton, xenon and radon. What is the atomic number for helium? 2. For neon, 10, 18, 36, 54, 86, correct? And here I will write the electronic configuration for the noble gases. All the noble 1s2, sorry, 1s2, atomic number is 2 and its electronic configuration is 1s2. And here helium 2s2, 2p6, neon 3s2, 3p6, argon 4s2, 4p6, krypton 5s2, 5p6 and xenon 6s2, 6p6. See here, except this helium, it is called a duplet. It is called duplet because it is containing only 2 electrons and all these are called what? Octet. Why? Because see here, the last cell, the valence cell is second cell and it is containing 8 number of electrons, 2 from S and 6 from Phi, 2 from S, 6 from Phi, like this. All these atoms are having 8 number of electrons in their valence shell. Therefore, according to this octet rule, all these atoms are stable, and because of their stability they are not involving in the bond formation, and therefore they can be available to us in their pure form, or they will exist freely in the universe. Helium gas, neon gas, argon gas, krypton, xenon and radon. But no doubt nowadays some experiments are going on to prepare the compounds which are containing krypton, xenon, radon. Okay, this is the first question and we get answer for this one. Why the atoms are combining? To get stability, and if they have 8 number of electrons in their outermost orbit, then those atoms are called stable. Then how these atoms are combining to form a chemical bond? There are two possibilities, either by the transfer of electron, from one atom to another atom. See, take an atom A which is having 9 number of valence electrons, and say an atom B which is having 7 number of valence electrons. Here this B atom wants only one electron to get a stable electronic configuration, that is 8, and here this A atom wants to lose one electron to get the stable electronic configuration of 8. Then now what happens, this atom A will transfer one electron to B, and now after the transfer this A atom will have the outermost electronic configuration of 8 and this B also have 8, either by the transfer of electron, and the second possibility is there by the sharing of electron. Say here atom A is having one electron in its outermost orbit, and atom B is having 7 electrons in its outermost orbit. Then now what happens? This is also unstable and this is also unstable. This wants 1 electron and this wants 7 electron. Okay. Then what happens here? This atom is also sharing 1 electron and this atom is also sharing 1 electron. Then now bond is taking place, the formation of bond is taking place between A and B, and here after the bond formation total number of electrons becomes 8. Here this atom is also having 8 number of electrons and this atom is also having 8 number of electrons. This is the stability forming by the sharing of electron between the combining two atoms. Okay. And if the chemical bond is formed by the transfer of electron from one atom to another, it is called ionic bond. And if the chemical bond is formed by the sharing of electron between the combining atoms, then it is called covalent bond. Okay. This is all about the basics of chemical bonding. Then in next class we will discuss about the definition and some of the examples for the ionic bond and the factors which are affecting the ionic bonding. Thank you.